This is the video for Chapter 3, Section 3, Part 2. Again, we're just completing the square. So we're going to look at some examples of how to complete the square when the number in front of our x squared, so that a is not equal to 1. So all the ones we've done in the past is when a is equal to 1. Now we're going to do some that a is not equal to 1. So this, we do the same thing, but it just requires one extra step. So we need to divide out our greatest common factor. So typically, our greatest common factor is going to be this a value. And we just look and see, is this a in common with all three of our numbers here? We can divide 12 by 3 and we can divide 15 by 3, so yes. So we're going to take out a 3. So we have x squared plus 12 divided by 3 is 4. And 15 divided by 3 is 5. And this is equal to 0. So if we divide both sides by 3, 0 divided by 3 is 0, and then the 3's cancel out. So we're just left with x squared plus 4x plus 5 is equal to 0. Now we want to check and see if we can factor this. Do we have two factors of 5 that add to 4? Nope. So we're going to have to complete the square. So that's when our b over 2 squared comes in handy. Our b is 4, so we have 4 over 2 squared, which is 2 squared, which is 4. So we need to add 4 to our equation. So we have x squared plus 4x plus 5 is equal to 0. So I left that space there so I can plug in this plus 4 in order to complete the square. If I add 4 to the left side, I need to add 4 to the right side to keep our equation balanced. So now, inside of our parentheses, we are going to plug x plus 2. That 2 comes from the number in the parentheses here. Can't forget the squared. And then I want to move the 5 to the other side, so I'm going to subtract 5. So 4 minus 5 is negative 1. So we have x plus 2 squared is equal to negative 1. Now we take the square root of both sides. So we have x plus 2 is equal to plus or minus square root of negative 1. We know the square root of negative 1 is I. So this is x plus 2 is equal to plus or minus I. And then we can just subtract 2 on both sides. So this is now x is equal to negative 2 plus or minus I. These are our two solutions to our equation. All right, we have 3 more examples just like that when we start off with numbers that are not 1. So first, we start off, a is 4. We want to see if 4 is divisible in all of our other numbers. So we can divide 4 by 4, 32 by 4, and 68 by 4. So I'm going to divide everything by 4. So now I have x squared plus 8x is equal to negative 17. So now we need to complete the square. So we're going to plug in our number here. That is b over 2 squared. Our b is 8 over 2 squared. This is 4 squared, which is 16. So we need to add 16 into our equation here, which means we have to add it on the other side as well. So now we have a perfect square trinomial that we can simplify into our binomial squared. So this is x plus 4 squared, which is equal to negative 1. So we take the square root of both sides. So x plus 4 is equal to plus or minus the square root of negative 1, which is I. And then we subtract 4 on both sides. So x is equal to negative 4 plus or minus I. Okay, let's take a look at number 11. So the first thing we want to do here is get rid of this 6. So since it's being multiplied to everything on the left side, we can move it to the other side by dividing. So we have x times x plus 2 is equal to negative 42 divided by 6, which is negative 7. Next, we want to distribute the x outside into both things inside of our parentheses. So this gives us x squared plus 2x is equal to negative 7. And now I want to complete the square. So we need to find what number gives us a perfect square trinomial. So we need our formula b over 2 squared. Our b is 2, so this is 2 over 2 squared, which is 1 squared, which is just 1. So we are adding 1 in here. If we add 1 to the left, we have to add 1 to the right side. And now our new binomial is x plus 1, because we get that 1 from inside of our parentheses there. And then that's equal to negative 7 plus 1, which is negative 6. Now we can solve for x just like we normally do. Take the square root of both sides. So x plus 1 is equal to plus or minus. I'm going to simplify this square root of negative 6 to I square root 6. And then I need to subtract 1 on both sides. So this gives us x is equal to negative 1 plus or minus I square root 6. Okay, number 12, we do the same thing. So we want to move the 2 to the other side. So we're going to divide both sides by 2. So we get x times x minus 2 is equal to 100. We need to distribute the x to both things in the parentheses. So this is x squared minus 2x is equal to 100. We need to find out what goes in the blank to complete our square. So we have b over 2 squared. Our b is negative 2. So this is negative 2 over 2 squared, which is negative 1 squared, which is 1. So we need to add 1 on our left side of the equation, which means we need to add 1 on the right side. Next, we need to simplify our perfect square trinomial into our binomial squared. So we have x minus 1, we get that number from here, is equal to 101. Now we take the square root of both sides, so x minus 1 is equal to plus or minus square root of 101. We add 1 on both sides, so x is equal to 1 plus or minus square root of 101. Alright, so the last thing we're going to do in 3.3 is write our quadratic function in vertex form. So if you notice when we had our binomial squared, it looks a lot like our vertex formula. So we are going to complete the square, get our binomial squared, and then we can identify our h and our k from our binomial. So first thing we need to do is complete the square. We have y is equal to x squared minus 12x. We need to put some number in here that makes this a perfect square trinomial. So that number comes from b over 2 squared. Our b is negative 12, so negative 12 over 2 squared, which is negative 6 squared, 36. So we are adding 36 here. If we add 36 on our right side of the equation, we also need to add 36 on the left side. But ultimately, in our vertex form, we want our y all by itself. We need that y equals. So instead of adding 36 onto the left, we can just subtract 36 on both sides. So if we add 36 on the right side, we need to subtract 36 on the right side as well. So we can do it this way where we have the y plus 36, but ultimately we're going to subtract it over to the other side. So we can just skip that step and just say that since we are adding 36 to complete the square, we need to subtract 36 also on the same side to keep our equation balanced. So 36 minus 36 is 0, so it's kind of like nothing's happening to our equation. So now we take our perfect square trinomial and simplify it into our binomial squared. So this is now x minus 6, and then we just need to add 18 minus 36, which is negative 18, and this is equal to y. So now we have our function in vertex form, and we have to identify the h and the k, because it says identify the vertex. So we know for our h, we get it inside the parentheses, but we have to change the sign, so this is 6, and the k is outside, so negative 18. Find some number. Okay, our last three examples are writing the quadratic function in vertex form and identifying the vertex. So first thing we want to do is complete the square. So this is y is equal to x squared minus 8x. I'm going to leave a blank for that number that we need to complete the square, plus 18. So that number we need to add to complete the square is going to be our b over 2, which is negative 8, over 2 squared, which is negative 4 squared, which is 16. So in here, we are adding 16. So since I'm adding 16 on the right side of the equation, in order to keep our equation balanced, I'm going to subtract 16 on the right side also. So if I'm doing both things on the same side of the equation, if I'm adding 16, I also need to subtract 16 on the same side. So now I can simplify it into our binomial squared. So this is x minus 4. And then 18 minus 16 is plus 2. So y is equal to x minus 4 squared plus 2. Now we identify our vertex, change the sign of our h, so this is 4, and our k is outside, so 4, 2 is our vertex. Let's look at 14. So again, we're completing the square. We have y is equal to x squared plus 6x plus 4. Some number that goes in this blank to complete our square. So we have b over 2 squared. Our b is 6, so 6 over 2 squared, which is 3 squared, which is 9. So I'm adding 9 in here to complete our perfect square trinomial. If I add 9 on the right side, I'm also going to subtract 9 on the right side. So since it's on the same side, I'm doing the inverse operation, because 9 minus 9 would just be 0. So now I simplify. So this is x plus 3 squared, and then 4 minus 9 is negative 5. So y is equal to x plus 3 squared minus 5. And then our h comes from inside the parentheses, we have to change the sign, and our k is outside the parentheses, which is negative 5. So this is our formula in vertex form and our vertex. Okay, for 15, we need to complete the square. So we have x squared minus 2x minus 6 in our blank here, we have b over 2 squared. Our b is negative 2. Negative 2 over 2 squared is negative 1 squared, which is just 1. So we are adding 1 in here. If we're doing the same thing, if we are doing it on the same side, we need to do the inverse, so we subtract 1. So now we can simplify this into our binomial squared, which is going to be x minus 1, because we get that number from what's in here. So x minus 1 squared, and then negative 6 minus 1 is negative 7. So y is equal to x minus 1 squared minus 7. Our vertex comes from our 1 and our negative 7. So we have to change the sign of our h, make it a positive 1 and negative 7. If we wanted to, we know how to find our vertex from standard form, which is negative b over 2a, comma, and then we have to plug that number in to find our f of negative b over 2a. So our negative b would be 2. 2 times a would be 2. So 2 over 2 is 1, which matches our vertex that we found. And then we plug 1 into our equation. So this would be 1 squared minus 2 times 1 minus 6. So this is 1 minus 2 minus 6, which is negative 1 minus 6, which is negative 7. So completing the square gives us the same vertex as we would if we did our negative b over 2a, like how we typically would if we had a standard form equation. But now we can just complete the square and identify our vertex once it's in vertex form. So this is always a good way to check your work if you ever doubt what you did here to complete the square. You can always plug it into your negative b over 2a and find your vertex this way, just to check to make sure you completed the square correctly.